I have upgraded my antenna to a 40-meter 20-meter fan dipole, and I have also upgraded it to include a common mode choke. Hello, my name is Aniruddha PU3FML. This video is about common mode chokes. I was going through this article written by Delta Juliet Zero India Papa. I will put the link to this article in the description below. It's quite a good read and it talks about common mode currents and common mode chokes. Let us consider a real world example. Let us consider a dipole which is fed by a coaxial cable. The center conductor of the coaxial cable will be connected to one of the arms of the dipole, and the shield will be connected to the other arm of the dipole. Now, at RF frequencies, the skin effect causes the current to flow over the outer surface of the conductor instead of the core. If we consider the current over the shield, the current flows over the inner surface of the shield. When this current reaches the feed point, it sees two paths. One is the path of the other arm of the dipole, and the other path is the outer surface of the coaxial shield. The current flowing over the outer surface of the coax shield is called as the common mode current. Since the common mode currents are flowing over the outer surface of the shield of the coax cable, the coax cable radiates RF. Now, usually, if the magnitude of the common mode currents is less, it will not create any problems. But if the magnitude of the common mode currents is higher, then it can create all sorts of problems for us. Here is one of the websites which describes the reasons to avoid common mode and what kind of problems it may create for us. It says that at the antenna feed point, the common mode current path forms a stub, effectively detuning your antenna. Furthermore, at the antenna feed point, common mode currents alter the radiation pattern of your antenna. In the shack and during the transmission, common mode coax sheath currents will interfere with your electronic equipment. In the shack and during reception, common mode coax sheath currents contribute to the reception noise floor, hence reducing the signal to noise level of desired signals. So we can see that at a higher magnitude, the common mode currents are definitely undesirable and may create a lot of problem for us. So the next point is, how do we stop these common mode currents? What can we use to stop these common mode currents? One of the solutions is to design a common mode choke. Here is an article written by Golf 3 Tango X-ray Quebec. He has done a lot of research on common mode chokes, and this article is a very good read. I will put the link to this article in the description below. He has summarized his findings in the chart that you see on the screen. On the right hand side, you see two sections: ferrite core common mode chokes and air core common mode chokes. Inside every section, it shows the common mode current choke being designed using different turns of different coaxial cables wound on different materials of the toroid. On left hand side, we see certain colored bars. The colors represent different values of impedance offered by the common mode choke to the common mode current at certain frequencies, which are shown on the x-axis. For example, the dark green color represents an impedance of greater than 8 kilo ohm is being offered by the common mode choke to the common mode current at that particular frequency. We also see certain black lines. The black lines represent that for a certain impedance that is being offered by the common mode choke, its resistive component is greater than the reactive component. He mentions in his article why the resistive component has to be greater than the reactive component. I will put the link in the description. Please have a read. So, what we are looking for is basically an impedance whose value is at least greater than 4 kilo ohms, preferably 8 kilo ohms, and whose resistive component is greater than the reactive component. So, what we are looking for is green color or dark green color with a black line. First, we need to choose the frequency of operation. In my case, I would be operating in the 20-meter band and in the 40-meter band. This vertical line represents the 40-meter band, and this particular line represents the 20-meter band. If we see here the second colored band, we see that for both the 40-meter and the 20-meter band, it shows green color with a black line. So, if we construct a common mode choke with 12 turns of RG58 on FT240-43 toroid, we will get the best possible impedance for the common mode currents. This particular table was updated by him. So for the type 43 material, we can see again that for the 40-meter band and for the 20-meter band, here we see the green color throughout with a black line throughout. So 12 turns of RG58 on FT240-43 offers the best possible combination to prepare a common mode choke for elimination of the common mode currents in the frequencies of the bands of 20 meter and 40 meter. Using this chart, you can design the common mode chokes that are suitable for certain frequencies. Now that we have established the proper way of designing a common mode current choke, we should also see another popular design, which is air cooled common mode current choke, which is popularly called as ugly balloon. According to me and according to this chart here, air cooled or ugly balloon is not preferable as a common mode current choke. The first observation that we see here is that there are no black lines, which means that whatever impedance it is applying for the common mode currents is a reactive impedance. The reactive component will be far too higher than the resistive component. This makes it undesirable for its usage in common mode current choke. The second thing that we observe is the range of frequencies for which the color is green or dark green is very small as compared to the range of frequencies over which a ferrite core common mode choke would operate. So, for example, if I want to operate on 40 meters and 20 meters, for 40 meters, I can see that only 25 turns of RG58 on a 4.25-inch core would be suitable. If I go to the 20-meter band, I can see that maybe 15 turns of RG58 on 4.25-inch core can be used. But the range is very small, and the same air cooled choke cannot be used over greater range of frequency. So for these two reasons, the air code is not preferred uh, for a common mode current choke. Here is the ferrite core 240-43, and we'll be using this to make the choke. We will also require a couple of cable ties or maybe more, a wire stripper, and RG58 coax cable. I have cut about 1.5 meters of coaxial cable. Now I have already used the wire stripper to remove about an inch and a half of the outer cover of the coaxial cable. I will remove the plastic film also. So this is how I've prepared one end. I'm going to put the other end of the coax through it, through the core, and tie this end with the cable tie. This looks good. And then we have to go on winding. So every time we put the coax inside the ferrite, it's considered as one turn. I will just remove this cable tie. Okay, okay. One, two, three, four, five. For the sixth turn, we will go inside and then come out the other side. So here we go. Okay, right. I hope it's clear. So one, two, three, four, five. For six, we went inside and came out the other end. Let me show it clearly to you. Yeah, one, two, three, four, five, six. Six went inside, came outside, and then we will continue on the other end the similar way. So that's seven, yeah, eight, that's nine, that's 10, that's 11, and that's 12. Now I will just have to fix this cable using another cable tie so that it doesn't, oops, so that it doesn't move. There you go. Okay, so what we did was, this way it will be clearer, hopefully. We started from here. Every time the coaxial cable goes inside the toroid, it's one turn. So one, two, three, four, five. For six, we went in and came out the other side. So this one is six, and then seven, 8, 9, 10, 11, and for 12 we went inside, and from the bottom we came out. Okay, so this is the exercise that's left. My observation is that for 240-43 toroid and RG58 coaxial cable, a little more than 1 meter is required, but just for safety margin we have taken a bigger coaxial cable. So that's it. And so on the other end we will remove, uh, let's say we'll keep a couple of inches or maybe more depending upon the enclosure in which you are going to fix this. I don't need much, so I'll just keep approximately, let's keep it here a little bit more. Yeah, all right. So we have made a common mode choke with 12 turns of RG58 coax on a 240-43 Torroid core. Here we see the completed common mode current choke. This end will get connected to the coaxial feed line, and this end will get connected to the dipole arms. Here we see the common mode current choke enclosed inside this enclosure. The center conductor on this side will get connected to the center pin of the SO239, and the shield will get connected to the outer casing of the SO239, and the coaxial feed line with PL259 connector will get connected to SO239. On this end, the center conductor will get connected to one of the arms of the dipole, and the shield will get connected to the other arm of the dipole. I've used cable tie mounts like this, which have an adhesive back, to mount the common mode current choke to the base of the enclosure. Here is the final antenna with common mode current choke installed. I hope you liked this video. If you have enjoyed this video, give it a thumbs up, and please consider subscribing to my channel. It gives me great motivation to make such videos. Thank you very much for watching.